Thank you very much, Susan. Welcome, Rohan, to our biostatistics seminar series. It's a great pleasure to introduce Rohan Alexander from the University of Toronto. Rohan is working on something which is modern and trendy and cool. And we need people like him to explain it to fuddy-duddies like me who are behind. But I think there's a lot of interest in this topic, more generally speaking. I'll just say a few words about Rohan. He's an assistant professor at the University of Toronto, jointly at the Faculty of Information and the Department of Statistical Sciences. He's also the assistant director of CanC Ontario, which is a pan-Canadian organization which encourages research and implementation of research, I understand, outside of university settings. He is a senior fellow at Massey College and a faculty affiliate at the Schwartz-Reisman Institute of Technology and Society. Interestingly, he is the co-lead of the DSI thematic program in reproducibility. His research investigates how to develop workflows that improve quality of data science. And he's particularly interested in exploring bias in data measurement and collection, whose data are systematically missing, and developing workflows and statistical models to adjust for that. I mean, what I grasp from all this is that he's going to help us to make our research more reproducible, which is really the need of the hour. So Rohan, I'll hand it over to you.
So thank you very much for having me, Nadi. It was a very kind introduction. I'm not sure what I really did to deserve that, but thank you very much. I'll just start sharing my screen. So you should have an R script open and just start sharing some slides. I need to get the. Oh, there it is. There's the chat. I see. So if folks have any questions, I'm well used to my students always interrupting, so feel free to just add into the chat or oh, is it screen share?
Yes, we can see your screen.
Yes. Yeah. Oh, we can see now we can see the slides.
Oh, very good. Yeah, so feel free just to add into the chat or ask, unmute yourself and ask a question. Hopefully next time we can do this in person. Montreal is one of my favorite cities, but of course with the pandemic, I haven't had very much of a chance to visit. I am Australian and have been here for a few years now. And my partner Monica, she's also in the Department of Statistics, but she's in the sociology department as well. If I may just take 1 minute briefly just to have a small ad. We're hiring. I'm on the search committee for assistant professors in data science methods for population health. You can see the job ad. You can see the job ad here. And if you have any questions, feel free to email France. The ad closes soon, so it'd be good to get a lot of applicants here. There's actually CRC options as well. Canada Research Shares available. So today I'd like to talk a little bit about what I see data science as, and then shift into what I was asked to talk about, which was reproducible research. I'm going to talk about three sort of tools that we can use to make our research more reproducible. So I'll go through R projects, through Quarto and GitHub. And then finally, we'll return to the opening question, which is sort of like, what is data science? Nadini said that the group typically has some comfort with R. So I've sort of based this around an R talk. And I am assuming some sort of comfort with R, but beyond that, there's not too many assumptions. And finally, none of this is sort of canon. My PhD is in economic history. I am not a statistician. I'm certainly not a biostatistician. So I would very much encourage you to sort of challenge my thinking and challenge my claims here, and I would very much appreciate that. So what is sort of data science? There's a lot of folks that have opinions. Nandini mentioned the Kansas, Ontario piece, and we had a research day a week or two ago. And as part of that, Mark Daly from Western, he said, well, I don't know what data science is. And he further said, well, I'm not interested. And his point was that to a large extent, if you're a university, and you can see that lots of universities have established data science institutes, if you're a university, it doesn't really matter, right? I mean, we use data science to get a lot of funding. It's wonderful. And if we maybe strictly defined it, then we might see some of that funding dry up. So maybe as an administrator, we don't want to. But as professors and as academics and researchers, of course, many of us have tried. So if you go to Hadley's book, he has one definition. Many of us are familiar with sort of Nick Horton. His sort of foundational teaching book also has another definition. Lake and Peng, another foundational sort of data science textbook, they have another one. And it's all about like information and getting some sense from the data. Tiffany Timber's new book has another one. But my high school debating coach, he would not be very happy with these definitions, because in these definitions, we are using, the words that we're trying to define. So we're using data, we're using science, but actually we're trying to define data science. So my high school debating coach would not be happy with these definitions. And so for now, and I'll return to this at the end, but for now, let's just say it's something along the lines of humans measuring stuff, typically related to other humans, and we're using sophisticated averaging to explain and predict. And why does improving data science matter? Well, it matters for a number of reasons. In my own PhD, as I mentioned, economic history. So there's been a reproducibility crisis in social sciences. We basically have very little idea what results we can trust. My boss at Kansas, Ontario, the director of Kansas, Ontario, is Lisa Strug, and she likes to say that biostatistics was the original data science because it married statistics with a particular area of application. But if we look back in history, of course, we see that this has happened throughout history of statistics. So the development of least squares was developed by astronomers, ratio estimators developed by demographers. And so improving the quality of data science really matters, even if it doesn't fit into any one particular discipline, right? Even if it's not necessarily statistics or not necessarily computer science. We've seen that p-values, we're not really sure how to use that. And Ryan Briggs, who's at Guelph, he has a recent paper where he's shown that power analysis in political science says that most articles do not have sufficient power to support their claims. And even in CS, there's a data crisis in CS where various authors are saying, well, nobody wants to do the data bit. And when they do evaluate the test data sets, they find that on average, labels contain around about 3% of incorrectly labeled data. And this really matters because, not necessarily because of, the journal articles that we publish, because, virtually nobody reads those, and that's okay. But because of where our students go on to get jobs. So they go on to consulting firms where they advise hundreds of clients. They go into police departments where they help set policy. They go into government where they help set government policy. And data science results are increasingly the most important in the world. But to a large extent, the emperor has no clothes, and we need to try and change. We need to try and change that. So in data science, I think that what we need to do is we need to try and focus more on telling stories with data. So the workflow that I advocate in my book is that we look around something like that goes planning, simulation, which of course has a large background in statistics, acquiring of data, exploring of data, and then sharing data. And basically what this is trying to encourage folks to do is just to think an awful lot, mostly read and write, and sometimes code. And so if we think of the key elements of telling a story with data. It involves communication, reproducibility, ethics, a whole bunch of different things. And the one that I'm going to focus on today is going to be reproducibility. So turning to reproducible workflows, we first need a definition of reproducibility. And essentially, we could look at it from what it implies. And so one thing that it could imply is that we share our code, our data, and the computational environment. And this is enhanced by using Quarto, R projects, and Git and GitHub. Reproducibility typically starts as something that's imposed on you. At least that was how it started for me. It was onerous, it was annoying. And this continued until I needed to revisit one of my projects after a small break. And at that point, I realized that reproducibility is not just a requirement for data science because it's useful for others, but it's also helpful for ourselves. Now, we use Quarto to build documents that integrate normal text, so normal words, and also R code. R projects enable a file structure that is not dependent on a directory setup. And version control makes it easier to share code and data. And I'm not saying that we have to do all of this immediately. I'm not saying that we have to do that analysis that doesn't do this is not worthy. I'm just saying that that bits and pieces of this will improve the reproducibility of your code. So why might you even care about this? So we firstly, as a science, we build on the work of others, of course. But if we build on results that are not credible, then we're wasting our time, but we're also wasting taxpayer money if we've gone and got a grant for that. If I talk to my colleagues in the statistics department and their theorists, they say, well, we've got a very well-defined way for what a credible result is. And, they then pass me pages and pages of their proofs. And for a long time, applied statistics and, other areas that relied on computation, they didn't have something that was similarly rigorous. And it's only in the recent years that we have developed the infrastructure, and there's an emerging consensus around what a rigorous claim looks like in applied statistics. So if a reproducible research means that it can be exactly redone given all the materials that's used, and that's fine, but there's different levels. So at a very first level, we would like that if I do some sort of research, I am able to redo the research and get the exact same result. Building on that a little bit more, we would like that another person can do the exact same research. As time goes on, we might like to be able to go back and be able to rerun our own research. And then we might like for another person to be able to go back and rerun the research. And so there's these different levels. And it's not about sort of insisting that we have to do everything perfectly immediately. We just need to try and make some small tweaks. More generally, it's a paradigm shift that's required. And so it's more starting to think about a paper as just an advertisement. And we see this all the time in our PhD students when we advise our PhD students, and they spend hours and months and weeks of time on their code and data cleaning, and they spend one day doing the analysis. And then we tell them, no, all anybody cares about is the analysis. And they say, but what about all the work that I did? And so I think that we need a paradigm shift here, and we need to think about and recognize that actually all of that code and all of that data that they did, that they cleaned and prepared, that is all the work. And the paper is just an ad for that. So how can we get there? So I'm going to talk about three things. As I mentioned, the first one is an R project. So what an R project is it is a way, and it's not just specific to R, but it's a way of saying that these are all of the files that are used for a particular project. And they all live in this one folder, and they're all related to each other. And why is this important? It's important because typically if you use some sort of setup, so like desktop/Rohan/stats/project1. If I try and give that code to another person, they're not going to have that same directory structure. And so you might say, okay, but why do I mind? I can just change it from Rohan Alexander, or documents, I can just change it to whatever mine is. And that's true, you can, but you can't do it at scale. Data analysis code these days typically has thousands or tens of thousands of lines of code, and one person cannot just go through all of that. And so we need to build in automated testing. I'm not going to spend too much time on that today, but we need to build in automated testing of our code. We need to take advantage of computers to test our code, and they can't do that if we use these absolute file paths. And so Anna Trezovic, who is at Harvard, she has just recently completed a study where she went through the Harvard Dataverse and grabbed a whole bunch of the R code that had been uploaded and tried to rerun it. So this is the other person running code at a different time. And she basically found that one of the most common errors that she ran up against was this use of absolute errors of absolute rather than relative file paths. So what I'll do is I'll stop sharing these slides and I'll just go through how you can create an R project and how you might use it. So we've got R Studio open here, and this is the only one that I'm going to do locally. I'll just make that a little bit bigger for you. Okay, so we go up here, we say file, we say new project. It's going to take a little while, and we're going to say new directory, new R project. We'll give it a name, so Talk, and open a new session. That just means that we're going to create a new one of these RStudio instances here. Okay, and so now we have this, and you can see that it's come up here with McGill Talk, and that tells us which project we're in. So if we were to close this, well, I'm not sure where it was now. I think it was documents, projects, and then McGill Talk. So we now have a file. And so if I want to do some work here, so we might have some inputs, we might have some outputs, and we might have a script. If I want to do some work, I double click on this R project file, and that then opens up the RStudio instance, and it is in relation to inputs, outputs, scripts. And so this means that if we then create a R script, so library tidyverse, we'll save it into scripts. So the code now exists, and it is in relation only to McGill Talk. And so I could package this. I could package this up, compress it, and send it to you. And well, that's my R, but and it would I could just send you this folder, and it would just be you would be able to run it by clicking on this R project. And so it's a tiny little change. All it does is all it requires is that we use our projects, and it just means that instead of having to worry about have file paths like documents, projects, book data, we can just have book data or book inputs, book outputs, and that enables anybody to then run our code regardless of the absolute file paths that they use. The next one is Quarto. And so Quarto is the successor to R Markdown. So this was released, actually version 1 was released only a few months ago. And what it does is it integrates code and natural language in a way that we call literate programming. It's a markup language, so this is the same as HTML or LaTeX insofar as we say, I would like this thing to be bullets, and then all of the bullets will always, oh, Nandini, sorry.
Rohan, I just wanted to request you to just say a couple of words about what R Markdown is. I'm not sure everybody has used it. I mean, it's probably unlikely everyone has used it. And even R Studio, not everybody may be using it on a day-to-day basis.
Oh, beg your pardon. Sorry. Thank you very much. So R and R Studio, they exist together. So this is R Studio here. And what it is it sits on top of R. So you can think of a car. And so R is the engine, and R Studio then is the vehicle that surrounds the engine. And it just makes the engine easier to do what we want to do, which in this case is to get from point A to point B. And so it's an environment where we can have our code in this top left panel here. We have a console in the bottom right. So if we just want to execute some R code, we can do that immediately here, or we can write a script to do that up in the top left. In the bottom right, we have files, or if we were to make a plot, then it shows up here. And then in the top right is the environment. So for instance, I'll just create a data frame so you can see. And so in the environment, it tells you what some of the variables and objects that we have created. We can click on this and we can view it. And so that's what R Studio is. So R Studio sits on top of R Markdown, and that's okay. I'll do it here, and then we'll see it again. We'll see Quarto in a moment, and so then you'll be able to see how similar they are. And so R Markdown is a way of combining these things. And so we'll just stick with HTML output for now. And so what we've got is a title here, example R Markdown. We have some text, so we could have an introduction. And then if we want R chunks, then we can put in here. So cars is a built-in one. So if I click knit, then we're going to get a document out. And so what it's done is it's integrated natural language. This is my informative introduction with R code. With R code here. And so this existed, R Markdown has existed for around about, I want to say 10 years. And one of the issues has been that these days people often use multiple languages. So you might use SQL to get some data from a database into your local environment so that then you can do your analysis in R. Or you might do some analysis, some data cleaning in R, and then you might do some data analysis in Python. And so for multi-language purposes, R Markdown worked, but it wasn't ideal. And so over the past year or so, the successor Quarto has been worked on. And so the Quarto, and we'll see it in a moment, Quarto is going to look very, very similar to R Markdown. And most of the differences are going to be for things like that. So for multi-language options and things like that. So the advantage of doing this is that we get a live document. And so we could see this here. So I could do a summary cars. I could do, I need to think of what else we could do. We could do car, what's in cars? So speed, so we could do cars, speed, max. And so if we were to rerun this, now we're going to get the maximum speed. And so this sort of live document in which we can execute code and then form a document that we can hand. So in this case, I'm outputting a HTML, but we could also output a PDF document is good because the code and the analysis, the written analysis are in the one spot. The disadvantage is that can take a while for the document to compile because by default the code needs to run. There's various options for changing that so that doesn't happen, but that is the default. Okay, so that is RStudio and RMarkdown. Nandini, do you think that that's an okay?
Yes, I think that's great. That's very good. I'll let anybody else ask if they have further questions. One point I'd like to add to what you just said is that you can knit into a doc file, a Word file, which I suspect many of the people in the audience use, especially because it allows track changes. So you're exchanging a document with a student, then I would suspect Word is a very common output option.
Oh, very good. Okay, so I'll do that for Quarto, just sure. Because it's it's been changed.
All right.
Right. So I just like to go through a few examples. So I'm going to pull up. That's fine. I'll just stay with this one. I'll just clean this up. Okay. So to get a new Quarto document, it's the same process. So we can go File, New File. And Quarto document. Okay, and so we can give it another example, a title, and you'll see that it's very similar. Word. So I don't use Word myself too much, but let's try it and see. Nandini, if this gets all wrong, then I'm going to blame you.
Yeah. Yeah, I'll take the blame.
Okay. Is it going to work? Oh my gosh. There you go. Look at that. It works. Right. I shouldn't have prepared anything. I should have just we should have just done it as a improv session. Okay, so you can see that we now have a Word document, and we've got as with our Markdown in the brief example of that, we have a title, example document, we have an author, we're using the format of Word, and we have some natural language. So we might like to go through and do various things. So for instance, here we have some headers. So we might like some different levels of headers. So we might have an introduction, and we're doing this with these pounds here. So 3 is going to be this next level header. So motivation, interested in statistics. Motivation and weaknesses. This paper is flawed. Okay, and so we can click render here, and then this should update. And so you can see now we've got different levels of headers here. We've got an introduction, we've got a motivation, weaknesses. We can have lists. And we can also have ordered lists. And so again, I'll just render this so you can see that we've got consistent headings here, and now we could have lists as well. And again, the reason that you might want to do this instead of just writing it all in Word is because we're getting this R code, we're getting this R chunk here. So for instance, let's put in some data. So let's create a data section. And so the way that we create some data is we have these 3 backticks, opening braces, R, and then a closing braces, and then 3 backticks to end it. So anything in this grayed out area is going to be R code. So we can have library tidyverse, we can have library AER, and I'm just going to use this to get some data. And the data is going to be on doctor's visits. And so I'll show you what that looks like. And so I can click this this green arrow here to run the whole trunk, and so we now have the data available to us, and you can see that it's come up here. It's in our environment, and so we can click on it and we can have a look at it. So this person, observation 1 is female. They're age 19. They've got an income of 55, and they've had 1 visit to the doctor. And so we might like to add a plot, remembering that this is one of the advantages of this approach is that we can integrate R and code. So doctor visits. And so we'll just make a histogram. Okay, and so assuming I haven't made any typos, if we re-render this, then our Word document should show up with a histogram here. Now you might say, okay, but I don't want all of this code and the warnings and things to show up in my final document. And of course, that makes a lot of sense. Oh gosh, I'm just aware of our time is running away. And so we can change the options up here around our code. I'll focus on Quarto, and we can leave version control maybe for another day, so that at least that way we have a lot of time for questions. So echo false, that controls whether or not the code is included in the document. So right now you'll see this, and you can see that the code is here in the document. And when I re-render this, we should remove the code. Okay, so the code itself is now removed, but we're still getting these warnings and messages. So we can turn those off. And what we should see is that we are largely left with just our histogram. And so at this point, we could actually add some analysis with some words surrounding this. So we can see that in this case, it's a histogram of illness. So we can say that most people were ill either no times or 1 times in the past week. So most people were ill only once. Well, it was at most once per. And so we're integrating this natural language with our R code here. So most people were ill at most plus 1 per week, and we've got the code there. We might like to do a cross-reference here. so that we can include something like, well, this is figure 1. And so we do that by adding a label. Graph. And then we add a caption. And so we're going to use the label, we're going to reference that, and then we're going to get out the caption. Oh, it was illnesses, wasn't it? And so we will reference that and we'll get the result here by at, and we're going to do fig example graph. And so we'll re-render this. And if I've done it correctly, then we should get a cross-reference. And so we can see here that we're getting this cross-reference here. So figure 1, and we'll get the caption that we said illnesses here. And yeah, so we could continue in this way. Okay, so it's 22. It's 22. How about I'll just briefly go on version control, and I did promise 10 minutes on it, so we'll see. If folks have any questions, feel free to please raise your hand. But we'll just move on to version control. So why might we be interested in version control? So it makes it easier to share code and data, especially as we work over time. So often, and this is how I started with version control, we'll create multiple versions of the same file. So we might say first go to R, and then we might fix some things, and we might say first go, fixed. We don't want to overwrite the changes, and so we create a new one. And very soon we have hundreds and hundreds of files. Then if you're anything like me, then you get a little bit smarter about it, and you start adding your date. You start adding the date to it. And again, the issue here is that it's very hard to know what changed between the version that we did on the 1st of January and the version that we did on 2nd of January, right? We have to go into those files and look at what has changed. And so we can steal from computer science here and use version control with Git. And what Git does is it takes a snapshot of a file at a certain point in time, when we tell it to, and then it takes another snapshot of that file again when we tell it to, and we will put in a message that says what the changes are between those two snapshots. Now, Git was developed by computer scientists, and it works very well for what it's designed to do, but it's less useful for people like me who are not computer scientists. And so there's a variety of solutions. And so one of those solutions to make it easier to use is GitHub. And so Git is to GitHub as R is to RStudio. So both, you can use Git by itself, you can use R by itself. That's perfectly reasonable. It's perfectly fine. GitHub just makes Git easier to use in the same way that RStudio makes R easier to use. And there's a variety of different options, right? It's not just GitHub. There is GitLab, and there's other options. But GitHub is the predominant one, and GitHub is built into RStudio Cloud, which is one. So I'll just briefly go through setting up Git and GitHub on a cloud instance. So just move this here. So we'll go RStudio Cloud. Oh, I'm gonna forget my password. So log in, and RStudio Cloud is just a version of RStudio that is based on their servers. The reason that I wanted to show it today is because it'll be a clean installation, so it would look like something like your students would be exposed to, whereas if I use my local version, then everything's already set up. So we'll go and we'll create a new project. Just get rid of these so that we have more space. So we'll go and create a new project, and we're going to create a new RStudio project. So most computers come with Git installed. So it's certainly already pre-installed on RStudio Cloud, but if you have a Mac, it should be pre-installed. And we can test this by opening terminal here. And we can say something along the lines of Git version. And if it spits something back to you, so in this case, it's telling us that we've got Git version 2.25.1. So that means that we've got Git installed. If you don't have it installed, then there's instructions that you can follow in Jenny Bryan's book. And I'll put the link. The link is, I'll show you here. Here. So Happy Git and GitHub for the user, and in particular chapter 6. Oh, okay. And so then what we need to know is we need to introduce ourselves. So we need to set it up. So every Git commit, and that's our snapshot, is going to be associated with a user and an email address. So in my case, I will add my own details. And we need an email address. And we'll know that it's been set up correctly because if I ask it for the config settings, if I ask it to list those settings, then if it spits it back at me, then we'll know that it's there, that it's been done correctly. And so in this case, it's spitting back, okay, username is Rohan, and my email address is rohan.alexander@userohan.ca. Okay, so that has been done. So then we can go to GitHub. And you can create a free account just by signing up. And so if you go through the process, it'll just ask you for an email address and things like that. It's free. And so once you've done that, it's something like this. And so what we want to do is we want to create a new repository. And so this is marrying the earlier idea of an R project with this is how we're going to use it. So everything will be within this one project, within this one folder. And so we can click the plus button there, new repository. And this is why we want to have an R project in the base of this repo, because that way everything will run in itself. So we're not going to worry about a template. We're going to just create a McGill. You can see that I cheated and I tested it all out before, so McGill already exists. But McGill example is fine. We can leave it as public. We can add a README, but that's okay for now. And a git ignore template. We don't want all of our files to be logged here, and so we use the git ignore template for R to just ignore some common files, and after that we'll just create a repository. So we would now like to be able to link this to our RStudio, and so we grab this clone this code bit, and what we're interested in is this username. Is this email, is this URL here. So we're going to copy it, and then we're going to return to RStudio. And so we might like to create a new project. And this time, instead of saying new RStudio project, we're going to say new project from Git repository. So we can paste in the URL. And so it's going to be linked to the repo that we started. And so the README that we created, for instance, which was just all it consisted of was the McGill example. So that was the name of it. We can see that it has been brought over here, and we could actually edit it if we wanted to. Now you might be worried, well, okay, so anybody could edit this. And so this is why we need to authenticate. We need to authenticate this. And so we need to, I'll just sign in. So that they're next to each other. Sorry, I was just signing in so they're next to each other. So we're in McGill example, and I'm aware of the time. We're not going to run late. And so what we'd like to do is we would like to create some sort of authentication ability. And so the way that we do that is we use the package use this and create pat. Beg your pardon, I need to install use this first. So what we're doing here is we're wanting to set up our local copy of our studio to be able to talk to our GitHub repo. So at this point now we should be able to create a GitHub token. Open the two-factor authenticator to and so this case here is going to be McGill example. And all of these things are okay. And so what we need to do here is we need to generate the token. And we want to be able to copy it. So I've copied it. And so we need to have this authentication here. So with git creds. Paste that in. Okay, so we've now created a relationship between our Studio Cloud and GitHub. And so the first thing to always do when we're dealing with this is to always git pull. And so we do this with the blue arrow here. And that ensures that any changes that were done in the repo since we last pulled are going to become locally. Then we might like to make our own changes. So we could change this to introduction. So we're changing the README here. And so we could save that as normal. And so at this point, we'd like to click on the files that we would like to do. So in this case, we might like to push the README. And so this is taking a snapshot. What we're about to do is take a snapshot. We're going to do commit. We're going to say what we did. So in this case, we might say that we update README file. We're going to commit it. And run. We commit it, and then after we commit it, then we push it. And what we would have seen is that the Miguel example would have updated here. The issue is that I have messed up the git configs. Right, it's 5.2. I'll keep going. We'll keep moving on. But if you wanted to see it, then it's in chapter 4 of my book, so you could go through it. I'm sorry that I messed up the git, the setup of the email. Okay. So just final 2 minutes. So returning to where we started. So what is data science? So I think that it's sort of the process of developing and applying this really tested and principled end-to-end reproducible workflow. I think that it's very much on that workflow bit. I think that it's focusing on quantitative measures in and of themselves, and also as a foundation to explore questions. And so this is where it separates from computer science, or it separates from statistics, because I think as data scientists, I think we're very interested in these measures in and of themselves. So some of the questions that the discipline might be interested in answering are sort of things like, how do we write effective tests? How do we check the data cleaning and preparation stage? What are some effective names, and other questions such as that. The other thing is, I'll just close, if you're a PhD student, the University of Toronto has just announced a series of postdocs with the Schmidt Foundation, and they're well paid. And so if you're interested in those, then you should email the relevant professor and look at that. But it is, yeah, now 3 minutes too. So I'll just say thank you very much again for having me, Nandini, and really appreciate the opportunity.
Thank you very much, Rohan. I'll ask the audience for questions. Very.
That was excellent, and I won't pretend I understood every line of code, because I'm a physician and epidemiologist, not a scientist by that at that degree. But I think what you really nicely showed us is, we've heard this word data science bandied about, and I mean, all science uses data and analysis and comes up with results. But I think you sort of really nicely illustrated to us that, well, it's about making all that background work, pulling it into the foreground and making it part of what's reported and shared and evaluated. I'm trying to wrap my head around, what does reporting look like? Does someone then, because we think of the journal article, as you referred to, as kind of like the ad, but it looks like you could delve in as deeply as you wanted, potentially into the actual data, potentially manipulating the programs that were run. Could you comment on, what is the reporting in this new world? What does that look like?
I think there's two aspects. And so in addition to the paper, I think that one small thing would be having a link to the code that the paper relies on. And so this might be linking to the GitHub repository, or you can actually deposit the codes at a repository that's separate to GitHub and that you don't have control over. And then the second part is the data itself. And I understand that in medical settings, that's obviously a little bit more
difficult. Yeah.
A little bit more difficult. But I think one nice step would be just depositing the code. And that's where sort of economics has gone. And so at the journal stage, you submit to a journal, and the top journals in economics now, they have these teams of data editors. The one for some of the top economics journals actually lives in Montreal, and they have teams that they rerun the code and on the data, because they sign all of the same confidentiality agreements. And so the data is never made public, but we're able to have confidence in the results because we know that at least somebody else other than the original authors has been able to rerun it. And so that might be another way forward in medical sort of settings.
Very interesting.
Just to add to Kabir's question, would reporting then not be the Word document that you showed us? I mean, that's the final product. Behind it are various levels of detail, but it's this HTML or PDF or Word document that's the report. Is that what you meant, Kaveri?
Yeah, it feels like you could delve to various levels of depth, right? You could have the Word document and a little bit of code. Then you could have the more detailed code. Then you could have all the versions of the code. Then you could run, but I mean, when I looked at it, I thought, wow, is that what all of our students should do? Is like kind of document at every stage using this this kind of interface. Yeah.
Any other questions? I'll say that I was actually surprised. I had no idea that you can access GitHub through our studio, and I've been using it for 10 years. And it's, I think it's, how do you keep up with stuff? I am not able to keep up. I think I know our studio and R to the extent that I need. And I find literally on a daily basis, there's new packages and, new things that you can do. How do you keep up? How do people generally keep up with this?
I find it very, very difficult. And I've increasingly needed to be more selective about what I do try to keep up with. And I find Twitter is pretty good with folks announcing their new aspects. I also just try to never start a new project and make a huge amount of changes. So I might just add one small change for the next project or one small change for the project after that. And eventually it builds on itself. So that's been my approach, but it is very difficult. I find that as well.
Thank you.
He's younger than you too, Nandini. That's
yes.
Younger than us.
Okay. Any some other question or comment from the audience? Okay, that's the question. Comment from Samani. But yes, I feel like especially during the pandemic, recognize like nature, I find increasingly have their code, the data and the code available in an appendix. So as a teacher, I found it very useful to go to these sources of information to recreate assignments, for example. It's been.
Yeah, and it's kind of scary how many of them don't work as well when you try to recreate them.
Okay. All right. So I think that you've given us a very clear talk, Rohan, and we'll probably reach out to you if we have questions as we try to navigate this new tech world ourselves.
Thank you
Thank
so much.
You very much.
Very much appreciate it.